Hello, everybody. My name is Viktor Moyseyenko, senior Python developer and also Python trainer and mentor for quite some time. And, and today, the subject and topic for our video will be a solution for one particular interesting task that is very common and popular on interviews, um, different testings of newcomers, especially. And in my practice, as I conducted a lot of interviews, I found this task a bit um, not super hard, but sometimes solved very kind of poorly, not optimal, not in not optimal way, and sometimes it was even not solved at all. But in fact, the task is super simple. So today we're gonna learn how we can uh, do such a solution for such a task, and also how we can analyze its performance and optimize it and refactor. Okay, so I'm gonna share my screen, and the task that we're going to solve today is called to sum. It's from LeetCode. LeetCode is a collection of different tasks, so it's definitely a good place uh, to uh, to to learn how to solve tasks 100%. Also, another one is called HackerRank. So also recommending quite a lot. And just as off topic, right? So for HackerRank, you can check tasks for developers, right? You click here, and you can, for example, learn kind of focus on Python, like Python, and you just go and look for different tasks, right? And you can filter, and yeah, quite a lot of them here as well. But probably LeetCode is more famous for the number of tasks and overall popularity. So we can solve the task right here, but I'm going to show you another way, probably more handy if you are starting learning, because solve in this IDE online is one thing, and solve it on your system is probably better for kind of long run. So I recommend you to use Microsoft Visual Studio Code for your, probably already using it, but just to VS Code it's called, and VS Code is downloaded from Microsoft site, right? And after you install it, of course, choose system, you need to go to this button extensions and search for Python extension. It's quite one of the popular, oh my god, 132 millions of downloads. It's quite enormous, right? So what you do, you just install, and after this, all your code, which you will write in Python code, will be highlighted. It will be with some, it will lint it. It will be kind of checked on different code syntax, correctness, and you will see code completion and other goodies. Okay, so it's very cool. It's kind of the first step recommended to do after you install VS Code. Okay, so assuming that we have this created or installed, we can create our file like to some task, whatever, doesn't matter. And since I have this extension already installed, I can see that it's being picked up immediately. So what we can do just go and see the solution, right? So let's talk about not solution, but sorry, task. So a task is quite simple. We have array in terms of Python, of course, list, right, of integers, nums, and one particular integer target. And so we have an example here. We have a list with 4, but it can be a different lengths of different lengths. We have target, it's 9, and we need to find indexes of items in this list, which, if we kind of summarize them, will be we will get this target number. So this means nums with index 0 plus num with index 1 equals 9, right? And also it's important part of task condition, you don't use the same element twice. And as an example here, right, we have 3 to 4. Theoretically, we could return 0, 0, right? 3 plus 3. But this condition says, okay, sorry, you can't do this. You need different indexes or indices. And you can see this third one is also about this. So we don't have here 0, 0, we have 0, 1. So because these are different items. Same value, but different items in list. So you can see this is a task. Okay, some constraints, only one valid answer exists. Okay, so this is it. Let's start coding. So what we could do, we could actually write some function here. We could prepare a list, whatever we saw, something like this, 3, it doesn't matter, right? We could even make it more interesting. We could insert something else in the middle, right? And yes, like here. So we have 2 and 7, 4 or 5. Okay, so 4 or 5 will be a result. So let's do this. Target equals 9. So we need to return to 7, meaning it will be index 1, 2, 3. So 1 and 3 should be the result, right? And we can start writing the solution. Okay, we can say it's list. We can use target. We can use annotation. So we can say it's a type should be a list. It should be integer, and this function, what it should return? It should return list, right? Okay, and what should we do next? We should kind of think of possible way of solving it, right? And during interviews, I noticed the first scene, guys are kind of imagining as a solution. They start thinking about this. So they have this list, right? And they start immediately kind of iterating. And so, for example, they take this one and they kind of create a next iteration for all other numbers, 4, 2, 5, 7, 3, 11, whatever. So for these 4, they are checking, is 4 plus 2 equals 9? No. 4 plus 5, by the way, it's also, we need to remove this if we want this 2 and 7 be a solution. So if 4 plus 5 equals 9, okay, we kind of get the result. So we need to return the first index and the index of this element of this 5. So we have kind of double iteration. So we have first iteration through all of these, right? And for each one, we need to iterate again through all elements and to check against all of them. If this doesn't work, no solution, we need to switch to 2, right? And we need to check this 2 with also with all of this. So we have kind of 4 conditions for loops iteration, right? So it's kind of super straightforward. So, for example, for X in this list, by the way, I'm using, you can see, using list with underscore. It's usual trick to avoid using built-in name of basic class, right? So with this, you can use it, and it's similar to what to the name of to last name of list, right? So it's very straightforward. Of course, we can do something like this, okay? And for example, if x plus y equals target, we could say, okay, you know what? We have solutions, because something like that. X and y are our solution. Remember, this is a kind of beta test, right? It's not kind of production code. We're gonna tune it quite a lot today. So target, why it's just back and forth. And this is it. What we can do, we can just go and run this particular script, right? And we can say Python to some task, boom. 4 and 5 are solution, 2 and 7, as I mentioned, right? So yeah, it's let's do something like 8, because according to our condition, there should be only one solution, right? But we see that 2 and 7 are solution and 7 and 2 solution. Why? Because we kind of iterated, of course, 2 times back and forth. So we firstly tested all items against this 2, and after we iterated and get to the 7, we also did kind of reverse the same operation, and of course we tested 7 plus 2. So theoretically we shouldn't do this, right? Somehow, probably we could just return after first kind of finding, okay? But nevertheless, this is not what solution expects. Task expects index of each element to be. How we can quickly get to the index? Of course, we can do something super ugly, like sometimes beginners are doing, which are super bad. It's a kind of bad example, but I'm going to show you kind of incrementing some index each time you go through this new element, but this is totally awful. Don't do this. And kind of bear in mind when you need to get index of element together with its value, best you can do is use enumerate. By the way, this kind of description help is shown by this Python extension that we installed. So we can see enumerate what it does. We just pass iterable. In this case, it's a list. And there is a optional start. By default, it will be 0. So what it does, it returns a tuple. The first element of the tuple is index, and next our item. So it will be kind of, let's call it I, and x, let it be x. Okay, so I, it will be the coordinate of this, let's say 2, and x, it will be the value. And the same let's do for second iteration, right? And okay, so this is how we change it. Let's run it. Boom. We need this, and we can just say, you know what, print kind of correct solution or final solution. Let's say final solution. Final solution is let's call it, I don't know, result. Okay, and sorry, I need to hide this again. Hide floating, and result will be, we need to return a list, right? According our annotation and also according our task condition. And for the first part, it will be I, first part, it will be J, right? So final solution is this. And sometimes you can just say, we're just gonna return this result right away. We find it, we're satisfied with it, it's cool. Just remember to enclose functions that return something with print to actually to be able to see something as this resulted value. Okay, so 2 and 7 our solution, 1 and 3, boom, we have, and it's super correct, right? And it seems that everything is good, but let's just test another values, another list. And you can see it will be annoying to write everything. So let's create a quick function to test solution. Okay, so solution, and let's call it func. Okay, and that's it. And that's it. And this test solution, what it's gonna do for let's create really quick test data, and we will have what do I want? I want first. I want. Yeah, I want two stuff. I want this list. Yeah, I don't. Yes. Okay. And I want a target. Something like that. Should be fine. We can create even a tuple. Remember, tuple is quite similar to list, but it's kind of more lightweight, right? And with this, we can just copy this. Sorry, it's our own. Let's copy this. And we copy this one, 3 to 4. We're gonna create some very short testing framework to be sure we don't screw up with our solution, which we do. It is wrong, sadly. So okay, let's save it. And 4 again. This is a tuple, so we can say test in test data. And is kind of constant. When you see in Python all uppercase, means please don't change me. It means some constant, and sometimes you want to emphasize this is unchangeable, some immutable data, right? So what is the test? Test will be this again list, right? So n will be test 0, right? Kind of first element is our test data list, and target will be test 1. Okay, it seems quite good. So what we're gonna do, we just can say print func, and func we're gonna pass n and target. Okay, yes, and we can also add expected values. So we expect 0, 1 here. So maybe it's becoming a bit more complex. So let's think for a while what we are doing. We have a list from 3 elements. The first element is another list with input data. This is target variable, and this is the value we kind of expect the function to return. Okay, so it should be clear. And 1, 2, 0, 1, 1, 2, 1, 2, and here 0 and 1. Okay, a bit complex, but you will see how it will work out. So we have expected value here. We can write something like testing, and we can with n equals n. What we are using is called f strings, kind of string interpolation. So we're just kind of injecting a value of a variable n just in the string. So we could see a result right away. Target equals target. And just to be sure, expected equals expected. Super nice. And we can say something like test passes. And we can here actually in this interpolation, we can execute code. For example, we can execute our function that we will pass here our toSum, and we can say equal expected. And we will see this will be a Boolean value, true or false. So we'll execute our function. Our function will return something like this result. And this result will be checking against this expected part. So kind of, yeah. And what we're going to do, test solution, our toSum. Cool. Okay, boom. You can see that our function it work. So 2 and 7 are our solution. 1, 3. Test passes true. Testing with 2, 7, 11, 15 passes true. But when it comes to this 3, we don't see, by the way, we don't see the result, which is not good. Not good. How we can do this? We can say actual. So actual is what function returns, right? So actual expected and actual equals actual. So what I did, I moved from here this part function execution to here, and we have this as additional variable. What this will allow us to do, this will allow us, let's comment this, two verbose, hard to understand what is going on. So now we can see that we're testing with this list, target, expected 1, 3, actual 1, 3. So these are fine, and this is what I was talking about. We returning 0, 0, right? 0, 0 when we expected to 0, 1 and 1 and 2. So why is that? Because we can see here we're enumerating through all of the list. So again, if we talk about these, so we have list. Oh my God, sorry. It's totally broken. Okay, we have these, and we iterating. For example, we are checking this 1, 2, 3, 4, and if we checking 1 against everything, for example, target is not 3. Let's say 4. Okay, and for example, we're testing this 2. 2, and of course we'll be testing against 1, against the same, right? And we will be testing against 2. It will return in sum, it will be 4, so we will return those 2. But this is wrong. Why? We can assume that we don't need to test these 2. If we're checking this 2, we don't need to check those, because theoretically everything kind of combinations for this one, for example, was already done before. Okay, so of course this wouldn't happen. It would happen if 2 were here, because with this one we probably would find the result, because 1 plus 3 plus 4. A bit messy explanation, but long story short, we don't need to repeat our iteration through whole of the list. So we need to start from where we left. So we left from what we have this I, it's for example 0. So we need to start from next, so from index number 1. We can do this with slices. Just for you guys who did, super beginner, just a few notes about what slices are. A very short kind of demo. So, for example, this is index 0. It's 2, right? And slice is like a part of list. We can say, give me a part of this list starting from index 1 and to the end. And we can do this with this slice syntax. So we can see we just got this part. So if we need from 2, it will be this one, right? 3, and so on. So we can actually use the same idea, and instead of course of 1, we can just say I, and it will be perfectly matching with this, but plus 1, right? Because we started from 0. Right? So for first, we need to start from kind of second and forward. So that's it. And it will be still broken because enumerate will still show you index 0, but it will be shown this index for shifted. So we need to shift also. Remember, we have the start. We can say I what? Plus, if it's no, just I, because for example, I'm thinking about 0, right? 0, the first one also 0. No, let's do the same. Let's test with the same. So start value should be the same as shift. Oh, you can see, boom, after magically we just solve it, right? So 0, 1, 0, 1, 1, 2, 1, 2. So this is a good solution, a bit complex this part, right? But you need just to kind of visualize that we need to shift. So for example, if we looking through this list, so we need to loop. We're going to check all items for these 4, right? But we don't need to start with 4. We need to only look here. And after we checked this, if we don't find anything, okay, let's switch to the next one. But we don't need to start from 4, right? Because we already tested it before, because we tested 4 plus 2, right? So we don't need to test 2 plus 4. It doesn't make sense. We already did this. So we need only to cover this part. So, and this shift is handled by this so-called list slice, like a slice of pie, okay? And this shift should be also tuned and accounted with enumerate, this start, right? So it will be and returning j not from 0, it will start from I plus 1. So it will say for the very first, for this 2, it will say 1. So I will be 0, j will start from 1. So that's why it makes more sense. Okay, so this is kind of cool. Congratulations, we solve it, but there is a problem with this solution, and it's a big one, and some kind of variations of this solution I see quite a lot. And the problem of this solution is mathematical complexity. You can see we iterate through all the list here. And if you're aware of this theory of mathematical complexity, right? Let's use slide medium. It means how much operations we do to solve this. So to do this, just this enumeration, you need to kind of do this operation n times, n kind of representing the size of this list. So in this mathematical complexity theory, this complexity of this line will be O from n. This is called O big notation. It means something very close to n. It may be 2 times n, maybe 1/2 of n, but it's kind of it's order of n. So it's most important part. It's not the exact number, of course, but it's kind of the idea how many steps you do. And you can see this second line, it's also O from n, right? And this means altogether our solution will take n square, which is awful. Why? Because if we talk about mathematical this complexities, you may, if you probably heard this quite a lot for totally beginners. I show you this small graph that is usually encountered, and you can find it everywhere. So in terms of complexity, there is ideal, not possible to achieve sometimes. In terms of algorithms, complexity of 1 or big of 1. This means whatever list, the size of your list, the complexity is static. It can be 5, for example, or 10, or even 100, but it means it's static. It's super cool because you have million of items in the list, but you will have just fixed amount of steps to do something. It's very cool and nice. And next, here goes a complexity O big of n. So you can see it's the same as this number of steps, sorry, number of elements equals to number of steps. It's just we have a square, square is going like this. So it's much worse. And there is a nightmarish scenario. It's called conversion task and factorial. It grows very quickly. So just for example, n10, it's just absurd amount of steps. And there is kind of optimized way, something like this, probably a bit up. It's all from n logarithm from n, something like this. So you can see the overall idea. And that n square is awful. Not quite awful as a factorial, but this even not it's not a valid solution sometimes. Okay, so this is the main problem for this one, for this kind of straightforward solution. So if we're gonna talk about how we can optimize this, we need to think about we don't need this anymore, this screen, because we have such a nice function with everything, with tests. By the way, we can just reorganize a bit the code. And what do we have here? So we have this the first, let's say, straight brute force solution. So we have it here. By the way, we can add some print testing function, right? Function, and probably as always in Python, everything in Python is object, so it will have some kind of name. So now we could see some captions that testing to some brute force, right? So this is will be nice printing out, and just add some footer. So in the future, if we create a few solutions, we could separate this result. Okay, this is good. So let's create a new solution which will be faster. Okay, so to some kind of fast, let's say. So it will take the same everything, the same footprint, let's say. And let's think how we can actually do this, how we can optimize this. The first thing when which is fast is dictionary or set, because operation on dictionary is super fast. Just in case you're a super beginner, let's briefly dive into dictionaries. For example, what? Sorry, X. We don't have this X. Let's do this. So, what is dictionary? Is a mapping? Mapping type. Mapping means we have some key, we have some value. So, dictionary. The difference with dictionary is that. Sorry, how to? How can I? Yeah. So the difference with dictionary and list. So you have indexes in list, but instead of indexes, you have keys in dictionary. So you kind of named indexes, some kind of something like this, and it's super optimized. So for example, this dictionary could have million kind of these pairs, and operation to find particular item in it is blazingly fast. It's actually what we discuss is O big from one. That ideal almost doesn't depend on the number of elements. So it's super cool and fast. So what we can do, how we can utilize this? We can create a dictionary first from all elements of this kind of target list, and then do only one iteration. And we actually will be taking this for and say, okay, our target is 9, right? And this means we need to trigger against only 5. Am I right? Only 5. So only 5. I need to find only 5. So I can just check, do we have 5 in this kind of in this list, which we're gonna transform into dictionary. So how we're gonna transform into the dictionary? Okay, so for example, we have this L. There is nice tricks from keys. From keys. No, not from. Why? No. We can do this with a nice trick called dictionary comprehension, but in case it will be hard to understand, let's do this slowly, and after this I will show you how we can optimize. So without further ado, let's create a new dictionary. Dictionary creates this brackets. No. Yeah, this curly brackets, let's say. Okay, and for X in list, which is the list of our incoming data, we can create but not in list, but in enumerate, right? We need indexes, remember, for the solution. So we say, you know what? X is the value and will be equal to I, which is index, which is cool. And after this, we will see a nice, cool dictionary with everything. Okay, so let's say really quick, let's test really quick here. Of course, indentation is wrong because we pasted it. So there's a way here we can do it's wrong anyway. Okay, doesn't matter. Sorry, we need to shift only this first one. Okay, and you can see we can see how this dictionary grows. So we took 4. It's the first element of our list. It's index 0. A second element is index 1, and so on. So at the end, we will have this nice dictionary, right? So what's next? We have this dictionary. What's next? Be one iteration again But remember, we don't do iteration inside the iteration. So we don't have this n square, kind of two loops. It will be something like 2n or some sort of it. So we can use again enumerate list, right? And what we can do, again, I, and we can say, okay, do we have this D? If we have, this means this is our solution. By the way, if you just do this, you are checking by key. So we are checking, do we have, like, for example, do we have 5 among keys? We don't, then we just don't execute the block which we're gonna write here. If we do, for example, if we trigger on 2 and we ask, do we have, I don't know, 7? Yeah, we trigger here, ask, do we have 7? Yes, we have. So we need just to return this index and this index, right? So we need just to say, you know what, return list, which first element will be y. It's our first element. And the element of target minus x. We kind of repeated this operation 2 times. I mean, target minus x. Theoretically, we could create additional variable like candidate with this to not repeat ourselves. It's subtle change, right? Maybe it's be more readable. So something like this. Okay. So we can do boom. We can do our test of another function really quick. Where's our boom? Oh my God. You know what? It just works. No, it doesn't work. So we returned 0, 0. Why? Because we tested, we said, okay, do we have target minus? We have the problem here, around here, right? Because we will have, that's right. Let me think. Actual 0, 0. So this means we tested that 3 and we returned right away. So how we can avoid this? How we can avoid? Again, we can do our old trick. If candidate D returning this, right? How we can say that we don't need to look through this one? Very good question. Just want to first understand why this works and this doesn't work. Because we have 3, right? Yes, and candidate will be 6. Yes, it will be. It will return the same. So we just need to add our condition. If candidate and D and D candidate, which is this Y, it should not be. It shouldn't equal to I. Because we don't want these to work, right? For this use case to happen. So let's run. Boom. We have it. Yeah, everything is working. So we have this additional step. We can even get this J equals D candidate. It will be similar to what we where it is. Sorry. J will be equal to D candidate, and we say, you know what, J not equal I, and we want to return IJ. So this is, does it work? No, it doesn't work because key error 5, Because what I changed, key error. I understand. Yes. Because you see, sometimes it won't be here, right? So you know what? Let's keep it there. Another solution will be to not directly access. This will produce you key error whenever you try to access something that doesn't exist. But you can also say, you know what, the get me candidate. In this case, it will return you none and won't produce you error. So we can do this here, but probably the previous one was also quite nice. Okay, let's retry. Boom, now it works. So remember the get, dictionary get, it returns the value if key is in dictionary, else default. And by default, where is the default? By default, it will be none. So the value is none, this object, empty object, let's say. So is this solution good? Kind of, but again, let's kind of calculate is this all from n? Is this also all from n? But it's not inside, so it's kind of, let's say, 2 all from n, but this usually discards. So this solution is also considered to be all from n. So very good solution. But maybe it's good, but we remember that we have to do these two loops, right? And probably this what could be optimized. Am I right? So let's try to think once more and create kind of third, even cooler, cooler solution. Let's call it perfecto. Perfecto. Just perfect. Okay. So what's wrong with this one? That we need to do this twice. Maybe we can do this in one go, because you see these two loops are looking super same way. So why do we need to do this twice? Okay. So let's try to a bit optimize it. I'm keeping this code, which also probably include or attach to the video later, just to see kind of evolution, right? So that's why I'm not changing this code. It works, okay. And so in your work, you can actually refactor your code, test it, and yeah, and change it whatever we need. Okay, so let's do this in one go. So we just let's kind of combine these two. So what we can do this. We can already calculate this candidate. So let's, yes, so we can say, do we have, let me think about this. So how we can do this in one go? But this is our task. We can check, do we have a candidate, this is J, candidate in D, in our dictionary, cache. If it is not in cache, then it's okay. Sorry, if it is in D and it is not. So basically, we're gonna repeat this part. We're gonna repeat it is not. What it if it's not? Maybe later it will be used. So if we don't have a candidate in D, right? We're talking about D. If we have candidate, it's cool. But if not, let's just populate it. Let's just create this current item and place it in our dictionary, because we need to populate this dictionary somehow, and that's how we do this. And what we gonna see, let's print D. Why? For our debug purposes, so we could analyze how it grows. Is it growing or not? Okay, so we even have something, and yeah, that's what I thought. You see, we kind of it works in a way. We see how it growing the dictionary, just as we saw ourselves here, where it is. Oh my God, so many. Absolutely like this, but it kind of gradually it grows as it processes items. And actually, it found result, but you see, it's just reverse order. Why? Because let's think of the very first iteration when you don't have this. We have two, let's say 7, just uh, 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 list of two items, 2 and 7. Candidate for 2 candidate is 7, and we're checking is it in D. And of course, it will be not in D because D is empty at this point, right? So what we're gonna do, we're gonna update and say, you know, def D from 2 equals, and after this, we're gonna start processing the 7. And for the 7 found in dictionary, right? And it is index will be 0, and we're gonna return 1 because index of 7 is 1, and we're gonna return 0, which is index of this candidate. So what we're gonna do, what we need to do is actually to reverse this order, right? In accordance with this logic, because that's why the problem, the difference with this solution to another one. So J I boom. Let's test. Boom, check, and you can see true. So we have everything working out super fast and optimized. Yep. So this is how we evolved from very not stupid but kind of fast when you are doing interviews. Sometimes you don't have a lot of time to think about optimization. So it's totally fine to write this. And then you're probably going to be asked, okay, what's the complexity of this? You can say, oh, you know, yeah, I know it's super slow. It's n squared. So probably we need to involve some data type which is fast, and a dictionary is super fast. Another fast object in Python is set, which is behaves just like now a collection of keys of dictionary without these values. So sometimes if you need to check that object exists in some group, it's sometimes smart to create a set from this group, and after this you can check afterwards whatever do you have this element in this set. It will be all from 1. And if you do some check using in, right, where is our in, like here, but instead of this D will be list, it will be all from n, because you need to check each element of a list. For dictionary and sets, you don't need to check everything, because there is an algorithm to check hash sum of this item, and there is a kind of logic how to quickly check is this hash belongs to the dictionary. It's super fast. Okay, so what we learned so far, we'll learn a bit more about dictionaries, even mentioned some set or class, and we learn how to evolve our kind of brute force-ish solution to something kind of also kind of very fast, and we optimize this fast variant to be this. You can remove this. Verify this. Probably yes, but currently it's totally fine. I see it's quite good. Change this a bit. Remember, the J will be known if it's not existing, so we don't need to double checking. We can just say if is not known, is not none. This operation is super fast. You see, I'm not checking like if it's not none, because this is checking by value. I'm checking by ID because I'm using is. This is one of the fastest operation in Python, by the way. So it's super fast. So what we don't need candidate, right? So we can just remove this, drop it here, and remove this line, and becoming more and more short. Yeah. So and of course, after each change, it's a good idea to check is everything is cool. So we have everything passed. It's okay. So this is it, guys. Hopefully it was nice demo for you and some ideas. And I encourage you to test the solution by your own. And you can just register here in lead code. Mr. Lead code, where are you? I'm have problems with internet a bit. So you just need to sign in as the problem just for tasks, and just find the number. After this you can submit your session and run against the test of it. This you can, right? And always try not to kind of copy paste. Try to write your own. When you do something new, you'll the brain will learn, and this will be kind of captured in your memory. Okay, so this is it for today. Probably see you next video if I find some more interesting tasks. We'll continue. So please write something, comment, feedback, what was good, what was bad, what maybe you want some particular tasks to be solved, anything. Okay, so that's it. See you guys. Bye bye.